Good morning. My name is Jim Milam. You're in my shop, and what we're going to talk about today is four-squaring a board. And I'm going to first talk about what that means by giving a definition, if you will. This is a board I'm going to work on. Two sides, two edges, and two ends, all parallel to each other, and all the angles at 90 degrees. That's the goal here. Why is that important? Here's a sign picture I took on the wall in Phil Lowe's shop. It says, if you can consistently make a rectangular shaped board flat, square, and straight, you're halfway there. That's what he thinks about the importance of four-squaring a board. Now, what can go wrong is, shown in this little photo, it shows a bow that is cupped, a board that is bowed, and a board that has twist or warp in it. Those three things you want to get rid of. Now, all that said, I want to demonstrate why you want to eliminate those problems. Here's our table leg. It has some taper on it, but up here where this stretcher is mortised into the leg, there's no taper. This is a double tusk mortise here. Imagine, if you will, this face is not square to that face. So if I cut the mortise parallel to this face, then when I put this together, the stretcher's going to run off either out this way or back this way. That can ruin your project. Here's another mortise and tenon. This face and this edge are not 90 degrees to each other. But I drill the mortise, or I cut the mortise in this piece parallel to this face. Slide the tenon in, and instead of it looking like this piece is going to run out this way or out this way. Suppose this is a drawer front. Suppose it has a little twist in it. Now if I cut the dovetails over here, and this joint's nice and tight, do the same thing over here. The joints are square to the end of the board, but the ends of the board are not parallel to each other. Here's what's going to happen. This side is going to, as it approaches the back of the drawer, this side will go up or down with respect to this side. Now try to put that twisted drawer, if you will, into the case opening and see what problems you have. The way to get rid of that is to four-square the drawer front before you cut the dovetails, both of which can only be overcome by these edges being parallel to each other and this side parallel to this side. If I made 4 of these, let's say I had a table, one of these faces is out of square. When I tried to pull all 4 of these together, the joint's not going to close, or the frame created by the apron and the 4 legs will not be square, and you won't have an even reveal around the underside of the table. All because something was not four-squared before the joinery was undertaken. How do we determine if something is four-squared? I picked this board because it has some twist in it. I trust the top of my table saw to be flat. I put this on here. So what I can tell from this right here, this board has a cup in it this way. This side is concave. I turn it over this way, and I can see the same thing. Now the concave side is down, convex side is up. Now if I did it on the edge, I can put this feeler gauge under here, and it slides underneath that part. It will not slide under there. It will not slide under there. So that's pretty straight. So there's a significant cup in it. There's also a twist. What I'm trying to do now is show the tools that you use to check if something is four-squared. This is a machined edge, a rather expensive one. This straight edge, which is nothing more than a 24-inch ruler that fits in this square. This is a straight edge. But in the case of this plane, this is plenty straight for what we're doing. Suppose that I want to check it for straight. Put a straight edge on it this way, and I can move it around, and by the way it moves, there's a high spot right in here, because that's where it's pivoting. So it's a little bit out of flat. It may not be enough to worry about in this case. Now what do I do about twist? I have a board 6 feet long. I'm making a table. I want to be sure there's no twist in that board. I can't do it on the table saw. I can't do it on the joiner bed. It's not long enough. So I've got to do it some other way. What we have here, what's called winding sticks. This is 2 pieces of maple, which is very stable, quarter sawn, and I have put a piece of wingy in here that's very straight. It's set in a rabbet, and then I put a piece on top to capture that. So I created a line of contrast, a color. And what I'm going to do is put this one on this end. I know they're both straight. If the top of this is parallel to the top line here, or the bottom line because they're the same, there's no twist. Go down to this end, I'll go out of the view of the camera, and I'll look back, I'll get down on eye level with these two pieces and see if that has twist in it. If I see twist, I get a piece of chalk and I can mark, hey, this is a little high right here, for example. The beauty of this system is I can move this one or this one and check it in another place and see where the high spot is. And I can move them back and forth. There's a twist occur between these two or between these two. Where's it high? Now I know where to take wood off. You can buy these, you can make them yourself, but accuracy in the making of these is paramount. That's how you check for twist and straightness. Now how do you check to see if edges are parallel, and how do you check angles? I get a marking gauge like this, mark a line on the edge that's parallel to this edge. Here's another style of marking gauge. This has a wheel, this has a knife blade. Does the same thing. It'll mark a line wherever you want it. Just mark it parallel. Does a very good job of it. It's very, very accurate. Now suppose I want to see if this edge is parallel to this edge. This is called a panel gauge, which is nothing more than a big wide version of this. Has a knife blade in it. Has a rabbet to ride on the edge here. You adjust it like so. Push that wedge in. Tap it like so. Put this right here. Mark a line. Very, very accurate. Mark a knife line. Now that knife line becomes what you would cut to if that was the width you set, a predetermined dimensioned width. So there's the line. Let's say that width is what I was after. I can, whether I do it with a joiner or a plane or whatever, I cut to this line. The next thing to look at are the angles. So you're going to have to go to a square, get a good one, buy the best one you can afford to buy, and you check for square and square. We want all these angles at 90 degrees. Here's a double square. Both of these have their place. Same result. Square, square, and this square as well. So those are the tools we use. So everything I've said applies regardless of how you go about foursquaring the board. I'm going to do it by hand. Brent Richardson's going to do it with a joiner and planer, and then John Hatten is going to do it with a CNC. Accomplishes the same thing using different tools and different techniques. So I'm going to look again and see which way is this thing cupped. This is the convex side, so I want it up. Because if I do it the other way, theoretically it doesn't matter which one you do first. Practically speaking, if you do it on the joiner or you do it by hand, the tool kind of follows the curve. You'll take off wood where you didn't intend to take off wood. So if you do the convex side first, generally speaking, you'll be better off. First thing I'm going to do is flatten the face. And you can see how it rocks. So it's high right through here. And I love chalk for marking this. So I'm going, in this case, I'm skewing the plane and I'm going approximately at 45 degrees across the board. So you can see the high spots. Now I'm going to turn around and go this way, about the same angle. This is a number 62, which is the equivalent of a number 5, but it's bevel up. This is a conventional a number 5 bench plane. So let's see what I got here. Let's see how we're doing. It's actually a little too low right here compared to this. I'm a little bit high right here. All the way across here, I'm still a little high. Now that is plenty flat for anything that we want to do with this board. By the way, this board is too wide for my joiner. I don't have one wide enough. I can do a board 10 feet wide with this tool right here. The surface left by these planes is unmatched. You can sand it till the cows come home. You'll never get a surface that feels like this. But now I want to get the thickness by marking like so. So I'm going to mark all the way around the board. And at this point you would set this marking gauge at whatever dimension your project called for. So now the edges are high and the center is low. I'm just using the plane for a straight edge. I'll back this off so I take off a little bit less. That's pretty much right on that line for thickness. It's uniform. Now let's do the edges. So what I'm going to do here is put it in this vise, and I'll use the same plane and clean up an edge. Planes tend to take a little bit too much off of here and here, leaving a hump in the middle. And it's because you tend to put too much pressure here and off the end. I was right, it does have a hump in the middle. So the way I'm going to get rid of that is I'm going to start it. I'm 2 inches in right here. I'm going to go like so. So it may actually be low in the middle. So I'm going to take off one pass over the whole thing. Yeah, now it's pivoting way over here, which is really what I want. If I'm using this to glue up panels, I want a little high right here, just barely, so that if the glue joint ever opens up, it'll try to open in the middle. More pressure will be on these ends, and it's less likely to ever open up on the ends where you can see it. Theoretically, I can put 3 or 4 boards side by side, and if they're all ever so slightly concave, pull them together with one clamp in the middle. That's all that's needed, because the pressure will spread out to the ends of the boards if they're all slightly concave. Now that I got this edge the way I want it, I want to take the panel gauge and put a measurement on this way. To show you that there's a different way. If this board were very long, this is a long shooting board that fits my bench like so. If I were going to put this in the vise like I did this side, if I were going to do it the same way. By the way, see this little splinter? That is a splinter cut by the plane on this side and the knife edge of the marking gauge that I had. That's how close it is, that little splinter. So what I'm going to do now, use a shooting board. Let me point out that I can do this with this plane right here if I want to. This little thing right here is called a hot dog. It's just a grip. It'll fit on here. You can buy that separately. This is hard to push in the absence of that. And I won't move it over there, but I'll just point out that if you can, if you want to. I'm almost to the line. I'm not trying to get this board to any particular point, but trying to illustrate the process. So now we've got two surfaces, smooth, flat, parallel to each other, and two edges, flat, straight, parallel to each other. Okay, now we're left with the ends. What this will do is it'll square the edge up to the extent that this stop is square to this, and the blade is square to the side of the plane. This will clean up the edge and square it up. This number 9 plane is made for this. And you can take the hot dog off and put it on the other side and use it on the left hand. So it's going to catch. It's going to catch back here because that's the high spot, if you will. The end of the board is very smooth. Of course, this is the end grain, and we've got it's square in that dimension, in that direction, and I'm going to check. This is the edge that was against the stop over here, so let's see how square this is. A 64th of an inch over here, and that could be a piece of dirt in here causing that. One of the problems with this, or the tendency, is you have to push the plane against the wood and the wood against the plane. You're doing this. Well, in doing so, there's a tendency to tilt the plane over, which will get everything out of square. You'll take more off the top edge here than you will the bottom. So you have to keep it down and to the left.
In this video session, we're going to talk about a process that has many different names, known as strategic milling, dimensioning, breaking down, or even four-squaring lumber. And it's a very fundamental skill that is necessary for every woodworker, and it's a skill that can be done many different ways. As you know, in woodworking, there are lots of different ways to accomplish the same objective. And so today we're going to be talking about accomplishing this using machines. The video is going to demonstrate the capability of taking a board that looks like this and transforming it into a board that looks like this. Yesterday, these two pieces were the same board. And so we're going to step through the processes today that it takes to take a board that comes as a rough sawn lumber and convert it into a finished piece of lumber that is ready for incorporation into whatever project you may have. As a part of that, we want to start today by analyzing the rough timber. And we want to understand, does it have twist? And twist is often indicated by opposite corners touching it at the same time. Cup would be the lumber that bends from side to side in somewhat of a concave fashion. Or bow. And bow is where you've got some sort of non-linear path along the length. And we won't be talking a lot about bow today, but these processes we're going to discuss will address both twist and cup. As you can see from this board, you take it and reference it against a known flat surface, and in this particular case there is no movement whatsoever in this board. You can also take a straight edge and lay it across the board and verify that it is indeed flat. You can take a square and look at the edge and verify that it is indeed square. And what you're looking for there as you put the square up to the board is to verify that you cannot see light under the square. And so in this particular case, the face is 90 degrees to the edge. So we're going to begin the process today by analyzing this piece of lumber. And this is rough sawn walnut. It's a 6/4 walnut. And as you can see, it has some twist. And so we'll take care of that twist, and we'll talk more about that when we get to the joiner. You can also see that I've laid out a rough rectangle here. That's the rough size of the finished product. You always want to begin with a piece of rough sawn lumber that is bigger dimensionally than your finished product. In this particular case, it's wider, it's thicker, and it's longer than the finished product that we want to achieve. As you can see, there is some level of twist, and so we'll address that. One of the ways I'll address it is you can see that I've marked the edge of the board. This is an area where we'll put additional pressure as we move the face of the board over the blade of the joiner, and we'll try to take care of the twist via pressure. We can also talk some other methods when we get over to the joiner. We're back at the joiner now, and so the first step in this milling process will be to establish one flat face. And some people might initially assume that the tool to do that would be the planer, but in fact it's the joiner. In this particular case, we're using an 8-inch joiner. An 8-inch will allow you to handle up to an 8-inch wide board. Some people have gotten much wider joiners. Strategy, if you have a board that is wider than your joiner, is to rip the board and then handle each piece, make sure it's flat face, and then glue it back together. I'll look at both the joiner and the planer as my apprentices. This would have been a situation back in pre-industrial times where apprentices would have done this work. This is one of the first skills they had to demonstrate mastery of, and so they would have done this type of work. As you can see from joining the face, that we now have a relatively flat surface, probably a little bit more smoothing to be done. One of the ways we can analyze the flat surface is to put a known flat edge on the flat surface and look for any type of rocking. I do see that we have slight rocking here, so we'll take a couple more passes through the joiner, and we'll discuss ways in which we can address that point. If you look at it end to end, we are indeed flat. So let's look at addressing the side to side, which means we still have a slight amount of twist in the board. So let's see if we can address that. One of the ways we can address it is by the use of wedges. You can put a wedge, and we'll take the board as we see it here. And we can look at where the high points and where the low points are, and we can shim up the low points until we get a flat edge, and then we can use double stick tape to adhere this particular wedge and run it through, and ultimately we can take out the twist. That's one way that we can do it. I'm going to attempt to do this by the use of hand pressure. By hand pressure, I mean that we'll push down on the edges that are high points and see if we can't flatten it in that fashion. So as you can see, we've got a much smoother surface, flatter surface, and as you can see from testing against a non-flat surface, we now have taken the twist out of the board. I prefer to do the edge next, so let's move in that direction. So the objective here is to create one edge that is 90 degrees to the face. And so we'll evaluate that by using a square and putting the square up to the face and verifying that the edge is in fact at 90 degrees. And we can tell that by virtue of the fact that there's no light moving under the square. So we have achieved a edge that is 90 degrees to the face. So at this point, we'll conclude at the joiner and we'll move on to the planer. where we'll establish a parallel face to the face that we've joined. We've moved to the joiner now, and so as I said, the objective is to establish a face that is parallel to the face in which we've already joined. We'll start the process by moving the joiner head to the approximate thickness of the material. We'll take a pass, we'll evaluate the cut, and then we'll take successive passes until such time that we've created two faces that are indeed parallel. At that point, we will have two faces and an edge that have reached their final state. We will then take care of the final edge. The objective here is to reduce the thickness, but in doing so, you don't want to take more than about 1/4 of an inch of thickness at any one session. Wood has to acclimate to moisture content, and so if you remove more than about 1/4 of an inch of thickness in any one session, you take the chance of significantly impacting the board and causing it to twist further. So now that we've got the twist out, we'll take some off to see if we can get two parallel faces that are indeed parallel. If we cannot achieve that, we will stop, come back to it in a couple of days when the wood has had a chance to acclimate to its environment. Again, with a board that was about 6/4, so let's measure the thickness now. Just slightly more than 1 1/4. So we've taken about 3/16 off the thickness of this board. We could take more if we needed to, but I think we now have two parallel faces. Let's check this particular face for flatness. We see no rocking in the straight edge. We see no rocking there, here, and we see no movement of the board. So we're comfortable that we have now achieved two parallel faces, one edge at 90 degrees. So we'll move to the table saw to take care of the final edge, and at that point we'll have a 4-square board. We're reassembled here now at the table saw, and you can see that I've used a mark to indicate the reference edge. This is the edge that we flattened on the joiner. This is the face that we flattened on the joiner. And then this is the face we flattened in the planer, and this is the face that we flattened on the joiner. So now we have three faces. The objective there is to take this last rough face, and we will achieve a smooth face here via the table saw. We want the blade to be to have almost a full bottom of the gullet at the top of the thickness of the wood. We will establish the thickness. In this particular case, we're just trying to get maximum utilization. So at this part in our process, we have achieved two parallel faces, two parallel edges, and we now have the board 4-square. We can verify that by looking at taking a square, verifying that that edge is square to the face. That edge is square to the face. That edge is square. So we now have achieved a 4-square strategically milled board using three different machines. The fourth machine that would be involved in the process is if we wanted to cut this board to length, we could then take it to a chop saw, miter saw, and actually cross-cut this board to length for our final stage in the process. But in this particular case, we have 4-squared this particular board, so the only point left would be to cut it to length.
My name is John Hatten. I'm a friend of the Guild. Today we're going to demonstrate flattening slab, natural edge slab on a CNC. We'll be using Freud fly cutter insert tooling, and one of the most important things is making sure that our slab is secure, level, it's not rocking. I've had to shim the 4 corners to keep it from rocking. Once we surface one side, we flip it over. We don't have to worry about the shims then. The next important issue is making sure that our slab doesn't move while we're machining it. And I have a stop at the front, back, and on both sides of it. Our design software today is Vectric VCarve Pro edition 10.019. Start today by creating a new file. It will be 12 inches wide and 20 inches long. Our thickness is 1 1/8 inches. We're touching off on the material surface, and our start point is in the center, so we want to move that to the lower left-hand corner. And we draw a polyline. Our polyline is 20 inches long. I'm going to change that dimension to 22 inches long. I'll make sure that is centered. I am going to make an array. I'm going to array copies. I'm going to have 1 row, 30 columns, 0.75 inches wide, which is half the width of our cutter. That's our step over. Copy that. We now have an array of polylines for our cutter to run down. We'll go over to Design, Toolpath. Our cut depth is going to be 1/16 of an inch, 0.65. We're using an 1.5 end mill, spoil board cutter. We're cutting on the line, calculate. We slow this down so everybody can enjoy, and we show the path of the cutter. We're doing a climb cut. We get our smoothest cut from a climb cut on a CNC machine in this particular application because we're reaching out and cutting the material rather than pushing it in front of us. Preview toolpath is complete. We'll save our toolpath. I'll save that toolpath to a convenient folder. We'll open our CNC controller. Hit initialize. We're initializing our machine, meaning that it touches off on the height, touches off on the X minus, and comes forward to the Y minus and touches off. And it always stops at X0, Y0 each and every time without fail. We will zero our X and Y at this point. Our start point on this is Y4, X6. So at this time, I will type in X6, Y4 command. The tool comes over to the Y4, X6. And that is our start point for this project. Our next step is to tell the CNC how far the cutter is away from the wood top. We do that with a touch plate. On command, it comes down, touches off, records that dimension. The software now knows the length from the cutter, the distance from the cutter to the slab. Air assist. We have to let this ceramic bearings, so it has to warm up for a few minutes. All right, we'll pull up our design, our file we designed, and that is Gill Demo, and I hit View, and it shows me the lines that it's going to run on. So we're on the same page. We can now hit Enter and start our dust collector. Nice flat slab now. To complete our 4 square, we would remove our clamps, turn the slab over, remove the shims because this is all perfectly flat now, and we would repeat the process on the opposite side. A little bit wider than your average joiner also, guys.